Okay, let's learn quantum computing without knowing anything about complex numbers, linear algebra, quantum computing in general, mathematics, or physics. All we need to know is the colors here, and the missing stage is the guy who tells us, please forget everything you know, please start all over again, please just look at the pictograms, because the pictograms do exactly what they say they do. So if you place the Z, it does exactly as in the image. So what does the image entail? Perhaps that to get to this channel, you need to have something that makes it look like it's going to pass through the channel. And now that you have it, you need to just revert it back using the same thing. Don't try to overcomplicate things. At the beginning, things are very intuitive. The visuals communicate everything they need in order for you to solve all sorts of quantum problems. All right, in this case, there are so many ways to solve it. So that's an efficient way, right? But if we look here, we have this gate. That's even a more efficient way, right? Because it contains green and it flips, and then the other one just flips back. Okay, now to get gold, we see there is a gold here, or we could just go green plus red. That makes gold, right? That's a solution, and another good solution is this solution. Of course, there are so many more bad solutions, but that's what you should look for. Okay, now we are being taught the idea that the human brain thinks linearly, and that's quite true. Everything in the universe seems to happen together in a quantum interference way. Yeah, so it's quite difficult for the human brain to do that, but eventually with enough exposure to quantum odyssey, you'll be able to think all of these things in your head without knowing anything about anything else. So to find a solution, let's just make the color gold, because we know the insides of the H gate do not contain any color, and that will just get us what we need. Yeah. Okay, now in this case we are shown the first yin yang. It's already built for us. What we can see is this is good with this. So let's just flip it and back it. Yeah, and all we need is to worry about what's happening on the one state. So this yin yang, because it's green blue, needs to become green red gold. If you multiply everything with -1, basically you just add red to green, green gold, green blue, then you will get red gold according to the color legend that you have in the game. Press Q, check the color legend, and things will be clear for you. Again, yin yangs here. Let's do the same thing. It might be a better way to do it. I don't want to show you efficient ways necessarily, but I want to show you things that can be done by simply thinking about it and just thinking out loud. You can find the solution. So in this case, you see green and blue will navigate green. So we'll have a green and we'll have a red. That's not what we want, right? Why I know that? Because I understand my color legend. So actually we do want this. We are here, and all we need is to flip to get here, right? So adding a simple X gate is exactly what we're looking for. Okay, now in this situation, a bunch of H gates. Let's just look at the bottom. Why we look at the bottom? Because H with H eliminates. Reversibility is a fundamental property of our universe. Everything can be reversed in our universe. We can all go back to the moment of Big Bang if we have the whole equation that describes everything that happened through entropy in our universe. So in this case, let me just add here green. Okay, and because this with this annihilates, this with this annihilates, this will give us something very close. Now we need to flip it, and we know green with red will make gold. And that's it. Okay, now we have two sigils of green color. We can either remove the color or immediately just collapse, because things of the same color, so imaginary parts or just real parts, will annihilate each other. That's how complex numbers work. But if we do this, we'll have to play with it a bit further, right? So make it red and make it blue again, and then flip it back. So maybe it's not the best way, right? So what else could be better? Let's use the Y gate to reverse the colors, H to collapse, and now flip it back. So we just saved one gate in the computation, which is amazing. That's what IBM wants us to do, to be able to create algorithms that actually can be used today, because of a lot of errors. So the longer the algorithm is, the less chances it might work on an actual quantum computer. All right, in this case, we have two sigils. Let's just collapse at the beginning. We've done this before. Wow, and we don't need to do anything. We just end up with the right solution. Again, okay, so here, we should just do again. The moment you see yin yangs, you know something like this has happened. Imaginary and real parts have combined, and you have a state that looks like this. Let's add the Y gate because we know both need to be flipped. And what does this do? Well, this one is correct, right? It's identical, but this one, So let's just add an S because S only flips half of it. And that's it. We have the right solution. And on the last puzzle, we have some interference happening. We don't want this yin yang, right? Like, remember the property of the H gate? It's reversible. So by just doing this and this, I make a bunch of explosions happen, but at the same time, make sure this green doesn't happen. Yeah. And now it's gonna be flipped. We can flip it back with an X gate here, or we could just do the same thing, right? Or we could just add an X gate here. So many ways to do things quantum mechanically, and some ways are always better than some other ways.